All right, so let's do one more example. Let's take a function, let's call it g of x. Let's define it as 2 plus x divided by 2x. Okay, let's find g prime. Well, this is something. Looks like a type of function we haven't learned how to deal with yet. This is a rational function, right? It's got a polynomial in the numerator and denominator. And when you have division, when you have a function divided by another function, we haven't learned yet how to take a derivative of that. So this on the surface looks like something that we don't know how to do. But if you get clever with it and do a little bit of algebraic simplification, then you can turn it into an equivalent format which can be differentiated using the simple rules we've already learned. So the first step is to mess with the function g itself. So I'm not going to try doing any derivatives yet. I just want to mess around with g. So let's take this division by 2x, and I'm going to distribute that division over the addition, right? Division distributes over addition in exactly the same way that multiplication distributes over addition. So that's pretty straightforward. And then I can simplify because 2 over 2 is going to cancel out and x over x is going to cancel out. So I'm going to get 1 over x plus 1 over 2. And now 1 over x can be written as x to the power negative 1. So now if I want to figure out g prime, the derivative of this function, all I need to do is differentiate the x to the negative 1 plus 1/2. And for that, let's do it in one step here, like pros. All I need to do is take x to the negative 1, apply the power rule to that. So I'll have negative 1 times x to the negative 2, right? And then the derivative will distribute over the addition, and then it will take the derivative, it will add the derivative of 1/2. Now, since 1/2 is a constant, it doesn't matter that it's a fraction, it's a constant, its derivative is 0. So this all ends up being the negative 1 over x squared, which is actually the same as the derivative of 1 over x itself. So this function, although it looked a little bit complicated, ended up being very simple with just a little bit of algebra cleverness along the way. So it's kind of like a puzzle. Sometimes you gotta get sort of clever with how you do your puzzles, how you do your derivatives, and sort of try a few things and see if you can simplify it in a way that'll make it easy. So I hope you have fun with this.